Welcome to our talk, Catch Me If You Can, Hunting Misconfigurations Before They Break Prod. So first something about myself. I'm product area lead for reliability by design, and I work for the global engineering and reliability department of ING. And I'm here with my lead engineer, JD.
Hi everyone, myself JD, and I work with Marcel in building the conformity bot solution to make the ING systems reliable.
Yeah, thanks JD. So first a small disclaimer, we don't want to get sued, right? So the agenda, first we'll talk about the why we need guardrails. And then we'll talk about the problem with firefighting. And then we'll discuss ING's target and vision and the design for a scalable solution, the closed control loop. And last but not least, our lessons learned and challenges. But JD will start with a couple of examples.
Yeah, sure. Thank you, Marcel. So we'll start with one of the incidents which caused the internet rumble in 2017. That was with AWS. So one of the engineers deleted the more servers instead of a couple of servers. So that was a wrong command, one engineer, but complete internet rumbled. It took off the systems in the S3 pool, and it created a lot of issues, and it also created a lot of instance because it couldn't serve the service request. And also one of the other reasons was clients had a hard-coded configurations in their file, and they didn't have a resilience pattern to switch to a second region if something happens. Yeah. So two problems. So one is like engineer deleting the servers, and second is about clients do not have the configuration to switch to a second region. And how could our policy help here? So maybe if you have had a policy as code in place, which prevents the engineer doing the disruptive commands, or maybe if you would have had a policy which could have informed the customers to have a resilience patterns to be followed. For example, in case if config file do not have a dual or additional configuration files to switch to second region in case of any failures, that would have prevented this incident. And second case is about GitLab data loss. Again, not sure it's the same engineer, but the engineer issued the rm-rf. Instead of secondary database, he issued the command in the production database. And that led to 6 hours of data loss. Yeah, it's not about the human error, but we feel that there is no guardrails to warn the engineer, or maybe there is no guardrails, or maybe there is no commands to check if the backups are working or not, right? So, but in this case, there were backups, but they weren't tested. Yeah, it was not recoverable. That's why GitLab couldn't recover the primary database. And could a policy be helped here? Of course, yes. If you'd have had additional guardrails, which could have prevented engineer issuing the disruptive command, or maybe if you have had a drift detection to check periodically whether the backups taken are good or in a good state or not. If you would have had such policies in place, you would have at least prevented these incidents. Marcel, you want to talk about shifting left?
Yeah, so we need to shift from firefighting to prevention, right? So firefighting leads to frustration, steals time from building business value. And it's not only about preventing incidents, it's about reducing the MTTR or mitigating risk with a progressive release strategy, for example. And yeah, ING target is an availability of 99.9. That's 40 minutes downtime every month, so that's not much, I can tell you. Yeah, we want to stay within our service level objectives and within our impact tolerance levels. And even though we have several layers of defense, known bugs and anti-patterns still slip through. So therefore we introduced guardrails, several guardrails. We have the well-architected review, which is an interview between reliability experts and system experts to find improvements and strong points and to share knowledge among all the entities and the teams. And we have our conformity bots. That's what we are going to talk about today. So automated checks on usage of resilience patterns, on high availability, etc. And we have static code scanning. Scanning our repositories, the code for known bugs and anti-patterns. And simplified, a guardrail. If you go off track, bumps you in the right direction and you just continue your journey as nothing happened, right? So that's a guardrail. ING, scale matters. You know scale matters. It makes things trickier, complexer. It introduces also for governance quite some challenges. So something about ING. So we have about 20 entities, countries, 20 CIOs, over 15,000 engineers, 12,000 active committers, 50 programming languages. Wished it was less, but a lot of programming languages, over 100 million lines of code, and 1 million pipeline runs every month. So number of repos, 30,000 active repos. And 400,000 policy checks per month, our policy checks. Quite proud of that, by the way. And 70,000 changes each month. I believe back to you.
Yeah, sure. Thank you, Marcel. So looking at scale of ING infrastructure space and the application space, we need to have a stronger vision backing the delivery of the applications, right? So to keep the systems up and running. And our ING vision is clear, yeah? So we wanted to have the reliability as baked in, not bolted on top of it. So we wanted to keep the resilience by design and reliability by design, starting from the design phase, yeah? Not only from the design phase, but also during code, also implementing code, deploying the code into production, also the drift detection from the production environments, yeah? And we treat all the changes, every changes in each stages as signals, and each signals are being monitored continuously. If there are any drifts or in case of any changes or misconfigurations, we use the closed control loop. We'll talk about closed control loop in a while, but we use the CCL closed control loop to detect the misconfigurations or the drifts and take the informed decision accordingly. And just to double click on the policy as code, we learn, you would have seen from previous examples, the Swiss cheese model, right? So whatever learnings we take from each stages or each levels, we convert them as code, policy as code. So for an example, converting a best practices as policy as code, converting the lessons, what we learned from incidents, we convert them as a policy as code. So these policies, when we roll out these policy as code or policies or guardrails in CCL, it really helps us, detecting the problems earlier. And with that, we introduce a framework. What we use at ING is called closed control loop. So think of it like cruise control in our car, right? So when we have a cruise control, when we are driving in a highway, when we set a cruise control turn on, you set a desired point, so desired state. Let's say like we wanted to drive at 100 kilometers per hour, yeah? And you set the desired state, and the sensors monitors the speedometer. Whenever there is an uphill and the car slows down, or whenever there is a downhill and the car fastens the speed, the sensors would detect the speedometer and sends the signals to the controller. And controller decides whether the car needs to be slowed down or accelerated. And controller sends back the signals through activators. In a car, we have throttle system, and throttle systems take the decision. If its car is going too slow, it will increase the speed. If it's going too fast, it will just break the systems. And it will again put back the speed into the speedometer. And this loop continues, yeah? So that is the analogy I wanted to highlight. And within ING, we have policies and thresholds which defines the desired state. We just define the a good state of the systems. And we have a monitoring system, like I mentioned. We have sensors which monitors the code, CI/CD environments, also the runtime environments. Yeah, and we have a policy engine which will monitor the data which is coming from sensors, and controller decides. So we use an open policy agent which will take the data from the sensors, and it will evaluate against the policies what we write in, which is basically a policy as code, and then sends the decision to the activators. The activators, either it will fix the code or raise a pull request back to the developer, or it will block the deployment. Yeah. And don't get panicked when we talk about blocking. We'll talk about that in a minute. And we also have evidence platforming for evidence platform to capture the results which are coming from the policy engine and take details from it for learning purpose. So with that, I just would like to pass here for 20 seconds. And as you see in the screen, it's a big diagram, but it is complex than this one. The closed control loop system, implementing them in a scalar ing is really a big one. But let's start with sensors. Yeah. So like I said, we have sensors in every stages. Yeah. We have sensors in CI/CD pipelines. We have sensors coming from the platforms, and we also have a messaging Kafka. So whenever the sensor detects something, it sends the messages to the Kafka event bus. That's what we have. And we have a controller here. And in the controller, we have a policy engine, which gathers the data from the sensors and does the policy validation against the policies we write here. So basically, metadata files, which will say like whether it's a global policy or a local policy, what kind of an action it should take, whether it has to allow a pipeline or block a pipeline or raise a pull request. So these results will be sent to the activators. And we have an activator which applies the results which are coming from controller. So basically, it will issue an auto remediation process, or it will allow or deploy a pipeline if action is needed in the pipeline, or it will create a pull request back to the developer. Yeah, and auto remediation, we use a lot of scripts like infrastructure as code or Ansible scripts to make corrections in the platforms. And we have most of our deployments happens through the CI/CD pipelines. Yeah. So and the decision is logged and put back to the developers for the auditing and learning purposes. That is from the drift detection part, and this is again a small flow diagram how it works in pipelines itself. Yeah. So in the pipelines, it's the same process, it's the same sensors and same activators. And it's just about a policy engine. We have OPA, which does the policy validation. And here we allow the deployments to progress in case if it meets all the requirements, all the standards, all the best practices. In case if it doesn't, then we stop the pipeline and put back the PR to the developer here. And we use a verdict store. So verdict store is basically to capture all those results, all those learnings, and we again do the iterative process of redefining the policies so that we can keep that loop going on. And some of the samples I would like to highlight. So we do write the policy as code in using Rego, and Rego within a policy will have multiple rules. And in case, as you could see, so in this example, we are looking for, our policy will look for deployment. We should have at least 2 replicas for high availability, and also it should have 2 connection strings for high availability for serving the database request. In case if your deployment file has single entries, if it do not meet the standards, if it do not meet the best practices as per the resilience patterns, then it would throw an error like shown in the example. And this is a good example where it meets the policy. Yeah? It has 3 replicas, 2 regions, it deploys in 2 regions, and it also has the database connection strings. So this is a very good example. I would like to highlight it here. And talking about the implementation itself, right? So as you see, there are a lot of stakeholders involved here. We are talking about CI/CD, we are talking about platforms, we are talking about the implementation plans itself, right? So it requires a lot of cultural things. So we have formed a governance board, and governance board have people coming from different teams, and they overlook the process here. So whenever an SRE comes up with the policies to improvise the system's reliability, he have to propose it to the governance board, and governance board assess the policies and the impact. And in case if they approve it, then that goes to the deployment state. And in the deployment state, like I said, we don't block the pipelines right away. We just start with the audit mode or information mode. Yeah? We provide the information to the developer, and we keep that cycle open for, like, for an example, 3 months. Yeah? So the developer has about 3 months of time to improvise the code. And in case if he don't change the code even after 3 months, then we will promote the refinement, or we promote the enforcement level to warning mode. And we again give a period window. And after that, if he don't change this at all, then we go to the blocking mode. Yeah. And every policy we implement in deployment state, it goes through again a review. So we closely monitor the impact what these policies are creating. And in case if there are any issues, or in case if there are any, for example, developers might complain about, hey, my pipeline is taking a lot of time, yeah, or you're inducing a lot of additional checks, which is causing performance issues, right? So we take those kind of a feedback from the developers as well, and we redefine the policies based on the feedback we collect. And after the process, in case if you wanted to retire, you can retire the policies, but we log them in the system for auditing purpose again, example SOX. But not every policies would be retained, right? So HA checks or reliability checks should be keep on going irrespective of the retirement period. And we are very much aware that there is no one-fit solution for all. And looking at the scale of applications we have, it's nearly impossible to have one-fit solution for all. So we have a room for various or exception process. But again, these exception process have to be approved by the board. And this doesn't come with a permanent exception, right? So it's a temporary in nature. We review them time to time. We take decision accordingly. And there is also a break the glass process, which will allow to skip these kind of a process in case of any major incident scenarios. And how are we scaling the guardrails at ING? We set the ambitious targets. So, and we start with the global standards. So we standardize the global requirements. So we take the platform minimum requirements. Examples, any container for high critical application should have 2 deployments at least. Yeah. So these kind of requirements and best practices we take, and we have it standardized. And we have local adoptions as well, because Germany, for an example, will have their local compliance requirements. Netherlands is different than Germany, right? So they have flexibility to adjust these policies. And we have a governance framework which will overlook all this process end to end. And we have an ambitious target to achieve, that is 500 plus policies and our guardrail rules achieved by 2026. Aiming for it, that we are on track. And what's a takeaway for you? I would say turn experience into code. Yeah. So if you have a best practices, or if you have learnings from postmortems, convert them into a code, policy as code. And then just don't look at the CI. Also look at the runtime environment. And don't think guardrails as a blocking mode, right? So the guardrails are like you have seen in the car example, right? So it's to correct ourselves. It's correct. It is here to help the engineers to do the right things. And not only the engineers, but it's also to keep the systems under monitoring, right? So we don't deviate too much. Our system don't deviate too much. So think guardrails as a guide, not as stopper, and close the loop. So starting from the beginning, you have seen 4 stages in the life cycle process. So use that loop and try to complete the loop, and scale smart with the help of governance board. And don't just look at the code, but also look at the environment. So shift everywhere. So with that, I'll give it back to Marcel to share. I shared only half of the story, right? So real pain is not about implementing a solution, but we also learned a lot from the field. So Marcel, you want to walk us?
Yeah, thank you, JD. So yes, we had quite some challenges, you could say. So I want to give that back to you. Our lessons learned. So first of all, it starts with awareness, right? Culture. So you have to create a single source of truth for your best practices. In the past, documentation, architecture, blueprints scattered around in the organization. You have to have a single source of truth for your, let's say, reliability principles and patterns. Be easy to find in the developer portal for your engineers. Establish a core team that can create community of practice, training, etc. And drive reliability forward with gamification. Because in my experience, if a good engineer wants to, he will find the loophole. Unaware engineer will try and bypass your guardrails. And yes, reliability isn't our target, it should be our default. So awareness, start there, create a single source of truth. So you have clarity about your best practices. And yeah, pipelines. So we are in the pipeline, maybe one of the crucial processes for our engineers. If you become a bottleneck or performance, and JD, we can tell stories that teams called us and the pipelines take 2 seconds longer. 2 seconds, right. And that's a problem. So be careful. And yeah, we learned that with this verdict store, maybe you saw that in the design, we try to do most of our policy validation asynchronous, out of the pipeline. We only read the verdict. The policy process, the controller already took place outside of the pipeline. It's not always possible. Aim for asynchronous policy validation. And yeah, shift left. Move as soon as possible in the build pipeline, in dev, test, etc. So you boost the confidence of your engineers. And maybe you know there's research out there, if you solve a bug in dev test, pre-prod, that's 14 times cheaper than solving a bug after implementation in prod. So we run our checks as early as possible in the software development lifecycle. Yeah, and maybe you know security event monitoring and other tools. They sometimes overwhelm you with false positives, so you ignore them. False positives is an issue, and I'll explain a couple of the challenges that we have. So I just said we want to do the check as early as possible. So in dev test, but sometimes in dev test I don't use reliability patterns or best practices. And in the code, how do I recognize if the code is used in production or only meant for production, test? We don't have a standard structure for repo, so I find code for dev test and production. This is where AI, by the way, comes in. We were just discussing, JD and me, that we didn't put any AI in our slides. That's a big mistake for this. But you saw auto-fix, auto-remediation, right? So we are working on AI for auto-fix. We are working on AI to analyze and to increase the precision of our policies. And last but not least, I said it has to be as early as possible. Of course, I want GitHub Copilot. And in GitHub Copilot, I want a code quality agent telling the engineer while he's coding what's the best practice, right? So, but false positives. If you have too many, that's a big challenge. And yeah, I still don't have immutable environments. There are still exceptions out there. I still have teams that use maybe Ansible scripts, but not the standard pipeline. So yeah, we need drift detection. Only policy validation in the pipeline is not enough. I need sensors on the environments, the platforms, the services to detect this drift detection. So the pipeline is not enough. Yeah, and I saw JD smiling before about blocking. We had big discussions about this. In the past, we said our team squads are autonomous. Now we say we have guided autonomy, right? So, big discussion, should we block, yes or no? Do a phased rollout, you first inform, then you do 3 months audit mode, and yes, then you block. But we had big discussions, and you could say it's still a little bit controversial, big word, but yes, we will block your pipeline. And there is an overlap with security. The availability from the CIA rating, that is security, right? So we closely align with CISO. And sometimes reliability collides with security. An example is that we want progressive rollouts. I want you to wait with your rollout between the availability zones, between the data centers, maybe wait 4 hours or 24 hours. Sometimes that means that the teams have access for 4 hours to high privileged account. Maybe CISO is not that happy about it. So ensure, and there was a good slide about the governance process, you have to have an approval board, governance board, and you have to involve CISO closely for those policies. I think that's it. Quite some time left, but I hope you enjoyed it. And if you have any questions outside of this event, please contact us. But I think we have time for questions, if there are any questions.